So in this first video, we're going to look at standard form for a circle. So circles, I mean, they're kind of like quadratics, little parabola-shaped ones, uh, but they are one of the conic sections. All right, so if you've got, a cone like this and another cone like this is kind of how they always start them. But if you've got a cone connected to another cone like that, like the tops are connected, when you slice this thing different ways, you get different conic sections. So if you were to slice this thing parallel to one of the bases of the cones, you would get a circle. All right. So standard form, the equation is like this. You've got x minus the horizontal movement squared plus y minus the vertical movement squared equals the radius squared. So it's kind of like quadratics. Remember, this would be like h units to the right because you're subtracting on the inside. And because you're minusing on the inside here, that's going to move it up. All right, so inside always works kind of opposite from what you normally think. All right, so we're going to go k units up and h units to the right. All right, so in this first one, to identify what the center. Oh, I didn't even explain that. Sorry. All right, so the h and the k, because that's how many they go to the right and how many they go up or down, that represents the center of the circle. All right, so HK is going to be the center of your circle. All right, now in this example, if we just want to identify the center, it's going to be 2 to the left. All right, so 2 to the left is going to be at -2 for x, and then 8 units up. So it's going to be an 8 for the y. All right, so the center of the circle is going to be at -2, 8. So -2, 8 is somewhere in there. That would be the center of the circle. And then the radius, over here, it gives you the radius. This number is always the square of the radius. So you know how 9 can be rewritten as 3 squared? All right, so I guess it's the square root of this is your radius. All right. Radius is going to be 3. So you draw a center there and then go out 3 units, and then you would fill in the rest of the circle if you were trying to graph one of these. Circles are not the easiest to graph. All right, so that's identifying the center and the radius. If, I just want to mention this, if the h and the k are both 0 and 0, that means the center is going to be at the origin. So the equations for those, they're always going to look like x squared plus y squared, because they're minusing nothing and minusing nothing. And that's equal to the radius squared. All right. So I want to mention that because sometimes that form pops up and it kind of throws you for a loop. All right. The next type of question here is whether a point is on a circle. So we're still working with this equation up here, this circle. The question is whether or not 1, 7 is on that. So you could graph it and try to kind of guess to see if 1, 7 is on there. It might be, it might not be. What we're going to do is just plug in 1 for x and 7 for y, and we're going to see if the equation balances, see if it gives us 9. All right, so we've got 1 for x, so that's 1 plus 2 squared, plus 7 for y, so 7 minus 8 squared. All right, and then we're going to see if this equals 9, so question mark there. All right, 3 squared is equal to 9. 7 minus 8 is -1, and -1 squared is equal to +1. So this does not equal 9. All right. So that would mean that this point is not on that circle. Okay. One more real fast. So is 12, -3 on this circle? So this one, it would have a center at 6, -5. That'd be the center of the circle. 6 to the right and 5 units down. And the radius for this one would be the square root of 40. I remember it's always this number. It's always the square root of that number, literally. All right, so if you're checking for this point on that equation, just plug in, 12 for x, -3 for y, and you're going to see if this gives us 40. All right, 12 minus 6 is 6, and 6 to the second power, 36. Plus sign. -3 plus 5 is 2. 2 to the second power is 4. And check it out. It does equal 40. There you go. That point is on that circle.